What it does is it moves forward. Oops, this one's going off the edge of the table. Okay. And what it's doing is it's got a set point here, which is about 200 milliseconds. And I can push it back, pull it forward, and then we can turn it around.
So it like follows, huh?
And it's a follow me robot.
It follows the flat plate.
Okay? And if you point it at a wall, it'll just sort of go up to the wall and stop. So we can do that. Let's just do it over here. I don't know. Let's do it a little bit. And this may try and go over the thing. I'll stop it. It goes over. Yeah, it went over. Sorry. Here. We're just going to have it run into your laptop. Isn't that fun? So give it a load and then we'll talk about how it all works. So if you go look at the code, right, which should be in your environment, first thing you'll notice is it's basically the same code as phase 3. Okay. So the code that drives the motors is unchanged. If you look down at the bottom, I deleted all the code that does the backup and turn stuff because this robot doesn't do it. And all the magic is occurring right up at the top of the program where we read the ping values. So we have LP gets the left ping. I don't remember the exact code. And we read the right ping. Then we have the left speed is equal to left ping minus left follow distance. Please, these are approximate names. I don't remember what I actually wrote. You should see it in there. So what this does is you're reading a ping value between 0 and 1600. I up the distance a little because we're not looking down at the table. And so if I'm here with the robot, okay, these are my two little sensors. What they're going to do is they're going to measure that distance and that distance. So this will be left ping. That was the right thing. Now, this is follow distance. Okay. Left ping is greater than that. So when we subtract it, we'll get a positive number. Okay. We know about negative numbers, right? Okay. Just wanted to make sure. They teach negative numbers earlier in school, which is a good thing. Similarly here, this distance is larger than the follow distance. So again, we'll get a positive. Things larger. This is back. Right. Okay. What that means is it's going to go forward. And then as it's moving forward, eventually, this one will be at the same distance. Your speed will shrink to 0, and that motor will stop. This one isn't there yet, so it keeps going forward, and it actually turns this way, but I'm going to draw it this way because I'm lazy. It will turn into it until both of the wheels are basically the same distance from your platform. Now, when we push this thing forward, now what happens is left ping is greater than the follow distance, and this goes negative, which turns the motors backwards and pushes them back. Okay? That's all there is to it. Now, it's an amazing behavior for that trivial amount of code. okay? And there's a bit of an issue here, okay? We're sort of nearing the end of the simple robot behaviors, okay? This is one of them, okay? Your tabletop robot is what we call an object avoider. It's avoiding the edge of the table. If you use this robot, take phase 3 and reverse that threshold comparison, it becomes an object avoider for the floor. Okay, so basically, whenever it sees something close to it, it'll back away from it. Whereas right now, it's whenever it sees a big distance that it backs away from a big distance. So you might want to try and tweak up your phase 3 to do that. This is a follow behavior, okay? If we had a line sensor on this, we do roughly the same thing. If we see a line to the left, we turn to the left. We see a line moving to the right, we turn to the right. Here you get line followers and stuff like that. So that's kind of where we're at with this kind of a robot, okay? Did everybody get theirs to work? Is yours working? Okay. Does anybody not work? Yours isn't working yet? We're going to come back to you, Gil, but we'll get it working. Guarantee it. Okay. So what I'd like people to do is go grab your phase 3 program, and I'm not going to give you the code this time. Go see if you can modify your phase 3 program so that when we put it on the floor, say, somewhere, see if it can turn it into something that will avoid the walls. Okay? And you're going to have to look at the code. If you have questions, we'll ask, and we'll help you figure it out. But I'm sure that by the end of the class, all of you will have an object avoider working. And that's kind of where we are with this level of robot. Okay? So now I'm going to go change context here, and we're going to talk about what do we want to do next. Okay? So officially, this class will be over as of tonight. But the whole purpose behind this robot is that we can do other things with it. It's expandable. Okay? Now, personally, the next logical thing to do is odometry. I'm not quite ready for odometry, though. What we want to do for odometry is these motors are very specifically purchased because they have this shaft coming out the back. And this shaft is a straight through shaft. Okay, and what we want to do is we want to put a sensor on the end of the shaft to measure the motor position. Okay, I'm going to draw what the sensor looks like. So this is the wheel. This is the motor. What we do is we put a magnet on here. We have to mount that in a magnet board. And then there's going to be a printed circuit board that has a little chip on it. And then this wire goes up, and another wire going up. And what that board does is it senses the magnetic field of the magnet. And it can give us a very accurate positioning of the wheel. Okay, up to divide 360 by 4,000. That's how accurate it is. Okay, it's about $5 for the chip boards. PC boards not very inexpensive, and the magnet's $1. We have to make a magnet holder out of some random plastic I have lying in the garage. And we would need 2 of those. That's where I want to go, but I have to actually get this debugged. Okay. Which I haven't done yet because I'm busy. Okay, so that's something I think we should all do. When we do odometry, now we can make our robot go in a straight line. In addition, we can do all the code that allows us to say, I'm in position here, and I want to go over there. And it will accurately go there. Up to you'll get just small amounts of slippage in your wheels. Eventually it'll get lost, but you know, there's things you can do. So we could probably make a robot that comes down here, turns right, goes down there, turns left, and goes out the door. We could probably get that to happen about 50% of the time if we did this, if we do odometry. I'm not ready for odometry yet. It's coming. I want it to happen. I have the boards. I have the chip. I don't have the holder yet, which I need to make happen. Okay, now the other thing is we can do, we can start moving up the food chain in terms of processors. This is an Arduino clone, okay? And, you know, not very expensive. It's not a very powerful processor. It's an 8-bit processor. We can do better, okay? Now, everybody here has probably heard of the Raspberry Pi. Anybody here who has not heard of the Raspberry Pi? It's an amazing little phenomenon that basically they came up with a really cheap $35 computer that runs full up Linux. You can plug in a high definition, an HD TV display, and it can fill the whole display. And it's got Ethernet, and it's got a couple of USB ports. And for me, the most important thing about it is something we call it unbrickable. Okay, what that means is there's nothing you can do to that machine, software-wise, that you can't fix. Okay, and the reason why that is because it will go to the little micro SD card that you plug into it. And if you screw that micro SD card up, you take it out, plug it into another computer, reload it, put it back in the Raspberry Pi, and go right back to where you started. So that's why we like the Raspberry Pi. Like that. Okay. They're about $35. You usually need approximately $10 for an SD card. This is the RP SD card. Usually you wind up spending another $10 to get a wall wart, something you plug into your electrical socket, and it has a USB connector coming out and plugs in. Usually, some frequently you can get less than $10. I'll call that the wall wart. Okay. There's really one other thing you do need, and that's the 3.3 volt serial connector. You can try and get away without it, but you're almost definitely going to need it. So at this point in time, I just tell people to get it. Okay, so you add that up, and okay, that's $75, which is more than we paid for the price of this robot. And that's why we didn't do Raspberry Pi for this project. Okay? Oops. It's very pretty. She needs more washrooms if we get them. Okay. So if people are interested in that, let me know. Okay? But I have another little confession to make here. Okay? We're not going to be able to do that much more with a Raspberry Pi than we are with this at the moment, unless you start thinking in terms of adding even more functionality down the road. Okay? So let me talk about what else we have to think in terms of. One of the things we need to do is we need to talk about batteries. Okay? Right now we're going cheap. We're using disposable batteries that basically, when we use them up, we throw them into the landfill. I'm not a huge fan of doing this, but I do it anyhow. There's cadmium in these batteries. It really don't want to throw them in the landfill. You really want to recycle them properly because cadmium is really quite poisonous. So what you want to do is use rechargeable batteries. And the rechargeable batteries aren't that expensive, but you need a rechargeable battery charger. Okay, so I usually wind up spending about $50 whenever I do a rechargeable battery and charger. Okay, so I just want to warn you that this is probably something else you want to be thinking in terms of. I usually have 2 separate batteries. Okay, one for the motors, one for the logic. We can get away without it, probably, but it's one of those things. Battery isn't what kills you, it's the recharger in it all. Okay? Yes?
So how do you feel about like a rechargeable double A battery?
I'm actually quite okay with that. Okay. And that's actually what I would recommend. There's this, you told me about it, it's the REM.
Analoop?
Analoop, no, there was another one that somebody told me about. You got them? What are they?
I love Anteloops.
What?
I love Anteloops.
They're Anteloops, okay, so I will.
I love them too.
So anyhow, I don't know how much these cost.
In quantity, about $2.
$2 a battery, so that's really not bad. You need the charger though.
Charger's about 35 for the
Charger's about 30.
really good smart charger.
Let me warn you folks, don't buy a cheap charger. You're wasting your money. Okay, so
The only thing you need the cheap charger for, if you have a smart charger, if these ever drop low enough, the smart charger won't see it. And you have to give them 5 minutes in a dumb charger to get the voltage up enough that the smart charger will take over.
take over. Okay, so there you go. So thank you.
Yeah.
I knew about these, okay, but anyhow, what we were looking at was about $35 for a charger. And let's call it 10 batteries, so about $20 for the batteries. Okay. And that brings us up to 55.
That's
So
probably-
I'm you know, some people say, I've had fun, but I'm moving on, I don't want to spend that kind of money. So we'll let people decide if they want to go down this path. Now, once we have the Raspberry Pi, we can do a couple of things. One, we can go down to Python. I don't know how many people made it to the meeting last month, the HPRC meeting a week ago. Okay, so I'm a big fan of Python as an educational programming language. Okay, there's lots of online courses for Python. There's books. It's taken over as the instruction language. And I really like the ability that we can do Python robots. So for those of you who were at the meeting, Bill Benson and I showed our Python robot. Okay. And what was cool about that was we were programming it wirelessly over the air. Now, again, this is the problem with robotics: is there's a little bit of a sticker shock. Okay, you need a Wi-Fi dongle, which is cheap. You need about $10 for a hub. Okay, now hub, it's called a powered hub. The problem with Wi-Fi is it takes a lot of power, and the Raspberry Pi can't provide that much power. So what we do is we take a powered hub, we open it up, and we add a wire, okay, and slip a wire here and there, so that we're basically taking the power from the battery directly as opposed to through the Raspberry Pi. I also forgot something over here. We need $5 for a 5-volt regulator. That takes us up to 8. Okay. So that's what we do. Anyway, we can do Python and Wi-Fi. We can also go down the ROS route. ROS stands for Robot Operating System. It was developed by Little Garage. Little Garage is still in business. I'm not sure what's happening with Willow Garage. We'll see. But they have forked off the Ross part of it to a dedicated nonprofit. I can't remember the name of it. And basically, it is the operating system that researchers now use to develop research robots with. Okay, and we have some expertise in the club. I have done very little personally with Ross. My robot, which if you go into the maker space, is the one that looks like a forklift. I coded that all basically before Ross showed up. Okay, and I haven't felt like recoding it. Okay, but we can go down the Ross route. Okay, and then there's one other thing going on, and this is something, how many of you went to the meeting again last week? 12 blocks? Okay, this robot can do 12 blocks. So if you want to do the 12 blocks thing, you can, okay? It costs money, it's not freeware, okay? Basically, Hanno has to make a living, so he has to sell his software. He's done a very good job on it, okay? I want to warn you though, the Arduino portion of his code has still got some rough edges, so you're going to run into bugs. But he's pretty responsive about fixing killer bugs. He's a little less responsive on the bugs that are just annoying. So just want to let you know. Now 12 blocks is where I would want to go for somebody who's not ready for Python. Okay? And I don't really know where people feel they are. I will tell you that programming in C and C++ in the Arduino IDE gets really rough after a while because it gives you error messages on a line number and you can't figure out what line that is. It doesn't give you enough identification. And it goes on and on. It's actually hard to program. I prefer Python, okay, but we can see. So I just wanted to sort of give people the lay of the land, and I'm just going to ask how many people would be interested in doing Raspberry Pi. That's kind of what I thought. Okay, you realize we're talking about $150 more, and the robot won't do a lot more than it does now until we start adding additional sensors, maybe a gripper, okay, and things like that. It's still just going to be a learning robot. It's not going to take out the garbage. It's it's just going to be people learning how to program and things like that. Okay, so it sounds like we're good to go. We're going to have to get people to pay up front so they can order the things. There's no price break buying Raspberry Pis. They are $35, period.
They
Okay.
have a newer version of.
They have the Raspberry Pi Model B, which is $25, but we're not going there. Okay, we really do want the Ethernet eventually as an option. You may have heard the phrase "penny-wise and pound stupid." Okay, don't save the $10 there. It's less than it's two trips to Starbucks is all you're saving. Okay.
The newer one is expensive.
Yeah, you just get the additional memory, get the Ethernet connection. We want to go there. Okay, so we're good to go. It is in parallel. I will get the odometry working. Okay, so by the time we have the Raspberry Pi up and running, we can go. How many people are going to want to go all the way to Wi-Fi? Yeah, that's what I thought. Okay, so we'll just build this up as a package: Wi-Fi, Raspberry Pi, and I assume everybody's interested in going to the rechargeable batteries. Okay, so as I say, I can't add that all because my brain doesn't work that fast. So we're looking at 80 plus 55 plus 20.
155.
What?
155.
It's going to be a little more than that, folks. Okay, so let's call it 175 is about where we'll be going. So if people are okay with that, we'll just start assembling the things. we'd be asking people to start PayPaling us probably around a week from now. We want to let the people on Saturday have a chance to decide if they want to go down this route. Okay. Yeah. And we'll just, the first step will be to get the Raspberry Pi loaded and up and running, and then we'll mount it on the robot. What we'll be doing is we'll be putting a Raspberry Pi platform somewhere on top of our robot to hold the Raspberry Pi, and then we'll be hooking wires between the Raspberry Pi and the Arduino, and we'll be programming the Arduino to talk over a serial port between the two, and then when it's all done, just to make it really clear, it's not going to do much more than what it does now. Okay, so just be aware. It's not until we have the odometry and start adding sensors and maybe a gripper that starts getting a little more fun. Okay, so I'm kind of done talking. I just wanted to let people know that we can move forward on this stuff. Yeah.
We were just discussing on the batteries and the chargers. We found Amazon's prices to be as good as any.
Okay.
And so how about if I just get you Amazon part numbers for a bunch of the alternatives, because people might want different levels of charger, different quantities of batteries,
Okay.
that kind of stuff.
I would
and
appreciate
it's
that.
going to be into the free shipping any way you do it. So.
Yeah, you'll get over that. So yeah, then I think you can just order it directly. We can't beat the seal.
So you
If
might
you
just
order,
want-
if you order through Hong Kong, you don't have to pay a sales tax. I actually believe that I'm paying sales tax. Okay, I'm kind of
You're still supposed to pay the California use tax.
You're supposed to. I won't go on camera and say you shouldn't do it.
Yeah, you better not.
Yeah, how many people here have done it? No, don't raise your hands. Because I have not. Okay. So, with that, why don't we see if we can take the phase 3 program and modify it so that it will run around and not run into walls. Okay? And we'll put it over there in the corner and see how many people can do that. Okay? If you're having problems, come see me and we'll start working on it. I'm going to work with Joe to figure out what's going on.
Phase 3 will behave like phase 4?
Phase 3 was doesn't run, and then it turns and goes somewhere else.
I'm going to call it
Okay, the
phase
only difference between
4.1 or something.
a tabletop robot and that doesn't fall off the edge and one that doesn't hit the walls, you have to convert the sense of the sensors, because when you go over the edge, the sensors go long. We want the exact opposite. When we get close to an object, we want to back up. So give it a try. Okay.